if XR is equal to this right hand side, we need to prove that the product of x1, x2, x3 up to infinity is -1. So for x1 we need to put the value of r equal to 1 over here, and then for x2 we need to put r equal to 2 again in this XR, and continuing this, getting the product, and then we get the result as -1. So writing the product on the left hand side up to infinity, and this will be equal to, okay, what is the value for x1? Just put r equal to 1 over here. We get cos of pi by 2 plus iota sine of pi by 2, and then for x2 we put r equal to 2, so we get cos of pi divided by 2 square plus iota sine of pi divided by 2 square, and then x3, that is cos of pi divided by 2 cube plus iota sine of pi divided by 2 cube, up to so on up to infinity, right? Okay, using the Euler's formula, what is that? E the power iota x is equal to cos of x plus iota sine of x, isn't it? I'm using this formula for the first bracket. Here x is equal to pi by 2 for the first bracket. So I can write this as e the power iota pi by 2. Can I write like this? Yes. For the second bracket, x becomes pi by 2 square. So it is multiplied with e the power iota pi by 2 square. And then for the third bracket, it becomes e the power iota pi by 2 cube, up to so on up to infinity. This product is up to infinity. So further, this can be written as e the power, we sum all these powers together and taking iota outside. So this is pi by 2 plus pi by 2 square plus pi by 2 cube plus up to so on up to infinity. Yes. If I take this complete to be equal to t, what I get? This is equal to e the power iota t. Yes. And again, using the Euler's formula, I can write this back to cos of t plus iota sine of t, where this t we have taken to be pi by 2 plus pi by 2 square plus pi by 2 cube up to so on, right? So putting this t value back over here, so this is cos of pi by 2 plus pi by 2 square plus pi by 2 cube up to infinity plus iota sine of pi by 2 plus pi by 2 square plus pi by 2 cube up to infinity. Now this bracket, inside this bracket I am having the GP series, the infinite GP series. What is the common ratio? It is 1 by 2. And what is the first term? It is pi by 2. And what is the sum for the infinite GP series? It is first term divided by 1 minus the common ratio. So writing this sum now. So this is cos of, okay, what is the sum? First term, that is pi by 2 divided by 1 minus the common ratio, that is 1 by 2, right? Similarly, writing the imaginary part also. So this is plus iota sine of the first term pi by 2 divided by 1 minus the common ratio. So this is cos of pi by 2, okay, divided by 1 minus 1/2, that is 1/2. So this is 2 into pi by 2. So this 2 is cancelled out with this 2 and we get cos of pi over here. So this is cos of pi plus iota sine of pi, right? And what is cos of pi? It is -1 plus iota sine of pi is 0. So we are getting the left hand side to be -1, which is the required answer, right? So we have shown this product to be equal to -1 using the Euler's formula. Alright, thank you. Stay blessed.